Okay, Crack the Whip is an old game that used to be played on a roller skating rink where you link up arms and then you try to form a straight line as you spin into a circle, and the idea is you try to whip the person off the end here. We're not going to try to kill anybody, we just want to get some data here, okay? So we need somebody who's feeling tired, who's not feeling very athletic to be our reporter. So someone want to be our reporter for us? Just record our data? Okay, Morgan, perfect there. Next, we're going to form a line, okay? So we need 8 people, or 9 people, 1 person to be the anchor, okay? So someone want to be our anchor? You get to be the center of the universe there, okay? Riley, how about, since you don't have fancy shoes there, you can just be the center of the universe there, okay? There we go. And then we need 8 volunteers really quick. We'll just add on to our line here, okay? Nick, you volunteered because you're just sitting right there next to your buddy. You don't have to move very much because you look a little bit tired, okay? Greta, you got nice shoes on, though I know you're fast, but we're going to have you be the next person there, so you don't have to go too fast. No biggie. Michaela, you got okay shoes on there? Yeah, you can walk in a circle, right? Yeah. No biggie? Though you got your big boots there, right? But you don't have to worry about running there. Okay? And then let's get some people over there. Oh, I'm saving you guys because you guys have some speed there. Yeah, okay? There we go. So let's throw in a couple other people. Let's see. Lucy, you got some big boots on so you don't have to go very fast. And then Colin, you can move. You got decent shoes there, right? And then now we need some speed there. Yeah, there we go. Who's got some speed? There we go. Who's got speed? There we go. You guys are fast, right? We're going to put you guys on the end, okay? We'll put Arland and Max on the end. So Max, you're going to really have to book it. We're going to need your speed big time there. Okay, and then Aaron will be number 6 there, okay? Got it? Okay? Everybody can leave all their stuff in the room. We only need Morgan, our recorder, to get data for us. We're going to head out. Let's rock and roll. So mass is always reported in kilos. Take weight in pounds, divide by 2.2. Okay? So never ask a lady their weight. That's rude, but mass is okay. Riley, go ahead.
57.73.
We'll just round it off to 58. It's good enough for our lab, okay? Thank you. Nick, if you don't mind. 80 kilograms. Thank you. Greta? 57. Thank you. Michaela? 61. Lucy? 43. Thank you. Colin? Oh, that's okay. You can just approximate. 64. Okay. Thank you. Aaron? 56. No problem. Arland? 66. And then Max? 67. Thank you. Next, we have to get the distances from the center, which Morgan recorded for us very kindly. So, 0 for Riley, 0.5 for Nick, 0.9 for Greta, 1.4 for Michaela, 1.8 for Lucy, 2.35 for Colin, 2.85 for Aaron, 3.4 for Arland, 3.9 for Max. Okay, perfect. Next, we had to determine the time for 1 revolution. The goal was to try to get around 10 times in the circle and then divide by 10, but yeah, it's really hard there, right? Actually, big time, common sense. Who's having a lot of trouble as we whipped around in a circle? Yeah, Max, okay? Because theoretically, everyone's spinning at the same angular speed, same omega, but definitely Max had a lot higher linear velocity, okay? So one thing is, like, some of your friends might be like total computer nerds, and they're into like video games and stuff like that. So one way to get your games to run faster is you actually redo your hard drive where you put all the data towards the outside track, because it theoretically loads faster on your computer, is the idea there, okay? I'm just happy my computer turns on half the time. So anyhow, the time for 1 revolution, you actually measured what, 2 for us, right? What was the time for 2 revolutions? What'd you get? It was 10 seconds or so? 10.4 is what you said? Okay. So then if we want to get the time for 1, we just divide that by 2, right? So it'd be 5.2 seconds. And is that different for everybody, or should it be the same? Same if we're just going in a straight line, which I know it wasn't perfect, but it's pretty close. Okay? So your goal to finish this lab is pretty simple. Okay? You're going to finish up a couple calculations. We're going to find the velocity of each person, there's centripetal acceleration and there's centripetal force. Riley's is really easy. She's the center of the universe. So technically, how fast is she moving in a straight line? She's not. She's just right in the center, okay? So if you think about it, theoretically, if you had like a record player, a CD player spinning, or you're on a merry-go-round, you could stand right in the middle and not feel anything because you're technically at that center of that circle, right? But as you move further out, how do you figure out how fast you're moving, etc.? So if you look on the back side, it's actually not that hard if you think about it. So go in a circle, how do you get the distance around the circle? How do you get the circumference? It's just what? 2 pi r, right? So if you know the distance around the circle, 2 pi r, and you know the time, then in question 2, which equation will give us the speed around that circle? The first, second, or third one? If I want to know the speed, I just take 2 pi r and I divide it by the what? The time, right? To go around the circle there, right? So, let's give you guys some work time then to wrap up your calculations and then answer these questions, okay? And you're going to see big time, it's already common sense. We already know who's going to have the highest speed, centripetal force, and acceleration. Who is our speed demon here? Right, okay? Max big time was whipping around the circle there. You see that? So what I like about this lab is it's fun to go outside, but it was very visual. You could see big time in a straight line. Who's feeling the most centripetal force and acceleration as we crack the whip going around there? And in the old days, you would play in a roller rink, and literally the person on the end was toast. They usually end up flying into the side of the rink there. Okay? So to go in a circle, you need to have a centripetal force and a centripetal acceleration. And that's what we're looking at here. Rock